This is section 6.2. This is part 1 of 6.2, which is multiplying and dividing radical expressions. Now we're just going to talk about the multiplying aspect of radical expressions today, along with a little bit of simplifying. The second part of 6.2 will be the division part. Okay, so our objective here, again, we're going to multiply today radical expressions. Okay, so it says here, you can simplify a radical expression when the exponent of one factor of the radicand is a multiple of the radical's index. We're going to talk about all that stuff. Okay, you can simplify the product of powers that have the same exponent. Similarly, you can simplify the product of radicals that have the same index. Okay, so for example here, again, this kind of goes back to the things you've learned in the past. The square root of a times the square root of b is really the same thing as taking the square root of ab. Or I can go backwards. If I have the square root of ab, I can split them up. And we've talked about this. Okay, but you'll notice on this one here, we have the square or the cube root of 4 and the cube root of 5, and we're able to put those together. Now, we're only able to put those together as long as your index or your root number is the same. If they're not the same, we cannot do that. Okay? So that leads into combining radical expressions. Again, if the nth root of a and the nth root of b are real numbers, then the nth root of a times the nth root of b is really the nth root of a times b. Okay, we can combine them as long as n is the same number. You might want to put that down there. This only works as long as n is the same, or the index. If the index is not the same, we cannot put them together like that. Okay? So it says if the radicand of the nth root of a has a perfect nth power, so if it's a perfect nth power among its factors, you can reduce the radical. Again, you reduce it by dividing. Okay? If you reduce the radical as much as possible, the radical is in what we call simplest form. For example, consider here, we've got the square root of 24 and the cube root of 24. Okay? Now you'll notice 24 is not a perfect square, and many of you were asking this question today in class, what happens if it's not a perfect square? And we talked about this a little bit. Okay? So, on these, you're going to need to be able to break down numbers. Okay? And when I say break down numbers, we're looking at ways to break them down into either perfect squares, perfect cubes, perfect fourths, those kind of things. Okay? So, as you see here, we've got the square root of 24. Well, we need to figure out what's the biggest perfect square that goes into 24, and you've done this before. Okay, this is nothing new. We break that down into 4 and 6. Well, we know that the square root of 4 is 2, or in this case they show it as 2 squared times 6. The square root of 4 is 2. We can't take the square root of 6, and there's no way to simplify it. So you end up with 2 times the square root of 6. That's the simplest form. We've done that before. That's not anything that's new. Okay. The part that's going to be a little bit different is when you do it with other roots, which is what you see here. Okay. So on the cube root of 24, we need to figure out what is the perfect cube that goes into 24. Now, if you break down 24 into a factor tree, this would be considered 4 and 6, and this is 3 and 2, and this is 2 and 2. So you could write this as 2 to the third, because there's 3 2's times 3. Well, you'll notice that this is a perfect cube, and that's what you need, because you have a cube root. So that's what they've done. They've broken this down into, in this case, 8 times 3, and 8's 2 to the third power. Okay, so really if you just break this number down, and put it underneath the root, you can do that as well. We can split them up, okay, because we have multiplication in the same root. So this is really the cube root of 2 cubed times the cube root of 3. The cube root of 2 cubed, these 3's cancel. So the cube root of 2 cubed is 2. And I can't take the cube root of 3, and there's no way to simplify that, so it just stays in there. Okay? You're going to see this a lot as we go through some of these examples. Okay, now let's take a look at some of these examples now. Okay, it says, can you simplify the product of the radical expression and explain? Okay, so we've got the cube root of 6 times the square root of 2. You'll notice that these roots are not the same. So can I make this the cube root of 12 or the square root of 12? No. This one you cannot simplify. Your answer would simply be the cube root of 6 times the square root of 2. They're not the same root. They don't have the same index. Therefore, you cannot simplify them. Okay? Okay, so now let's take a look at problem B. Okay? We've got the cube root of negative 4 times the cube root of 2. Well, I know that these two are the exact same root. So what I'm going to do is I'm going to combine them and make this the cube root of negative 4 times 2, which is the cube root of negative 8. Okay? Now, look in your cubes, look for 8 on your index chart, or on your exponent chart, and you'll notice that we have 2 to the third power is 8. So really this is written down as the cube root of negative 2 cubed. And then you'll notice your cubes are going to cancel, and you can simplify that to negative 2. Okay? All right, let's take a look at these two examples over here on the right. What's the simplest form of the cube root of 54x to the 5th? Okay, now, many of you are asking this question. What happens when things aren't divisible and all that kind of stuff? Now you're going to start to see those, and we're going to start talking about this. The first thing I want to do is I want to break down 54. So 54 into a factor tree is 9 times 6, and 9 is 3 times 3, and 6 is 3 times 2. So I'm going to rewrite this as the cube root of 3 to the third, because there's 3 3's, times 2, times x to the 5th. Okay? Now, as I look at this, I want my exponent to match my root. This one it does. This one it doesn't. There's nothing I can do about this. But I can break this 5 apart and get 3 out of those 5. So again, you're using your exponent rules. This now would go to the cube root of 3 cubed times 2 times x cubed times x to the second. Because remember, if I take my exponents and multiply, or if I multiply, I add the exponents, so I can break that apart. It goes back to your exponent rules. Now, I want to look to see what things can I cancel. Any cube will cancel with the cube root, and it's going to move it to the outside of the root. So the 3 is going to move to the outside. This x is going to move to the outside of the root. The other things that I can't simplify will simply stay in the root. And now you're finished. Okay? You've now simplified. That's the simplest form of that root. Okay? All right, 128. Got to break down 128. Okay? So 128 is 16 times 8. Well, I know 8 is 2 to the third. 16, 4 and 4, 2 and 2, 2 and 2. Okay? So, really, you have, as you look at this, okay, if we break this down, I've got the cube root. There's 3 here, 4, 5, 6, 7 2's. So I've got the cube root of 2 to the 7th times x to the 7th. Okay? 2 to the 7th times x to the 7th. Now, as I look at this, again, I want my exponent to match my root as many times as I can. Well, I can break down 7 into 3 plus 3 plus 1. So really, as I look at this, I could say this is the square root, or the cube root, sorry, of 2 to the third plus 3 plus 1. That's 7 times x to the third plus 3 plus 1. That's 7. So I'm going to rewrite this guy now. This is the cube root of 2 to the third times 2 to the third times 2 to the first times x to the third times x to the third times x to the first. Okay? Now, all my cubes, all of the things on the inside of the root that have cubes are going to move to the outside. So, as I look at this, this is going to move to the outside, this, and this. So I have a 2 times 2 times x times x. And the things that I can't take out are going to stay in here. These are the 2 that I can't take out because they don't have at least 3. So now really this is 2 times 2 is 4. I have x times x, which is x squared, times the cube root of 2x. And this is my simplified answer. Okay, so you're going to have to be able to simplify these roots. Okay? All right, now multiplication. We'll go through one more example of multiplication, and then the last part of the last example, I'm going to have you try and finish on your own before you come to class tomorrow. Okay? So what's the simplest form of 72x cubed y squared, the square root of that, times the square root of 10xy to the third? Okay, first thing that you can do here now, okay, since we have multiplication, and we're going to kind of, as I look at this here, I want to break 72. What perfect square goes into 72? Well, we've got really 72, if I break this down, and matter of fact, we'll just multiply these together so it'll make it easier. Let's go the square root of 720, because 72 times 10, x to the fourth and y to the fifth. Okay, using your exponent rules. Now, 720 breaks down into 144 times 5. Now, since I have a square root, I'm looking for the largest perfect square. So this one's a little bit different. Now you can break it all the way down and get 2's, but it's going to take you a little bit longer. Okay? On this one, I'm just going to make this the square root of 144 times 5, because 144 is a perfect square, times, I want 2's, so this is x to the second and x to the second, because remember, 2 plus 2, 2 plus 2 is 4, okay? And then I also have a y to the second times a y to the second times a y to the first. All of those will add up to 5. 2 plus 1 is 5, okay? So now everything that is a perfect square is going to come out. The square root of 144 is 12. I should have an x times an x times a y times a y. Those are all going to come out because those are all the 2's. Those 2, these guys, and that. And you'll notice what's left over inside? A 5y. And now I need to simplify this, clean it up a little bit. It's really 12 x squared y squared times the square root of 5y. Okay? All right, so this concludes part 1 of section 6.2. I need you to complete this last problem on your own. See if you can come up with an answer before you come to class. Okay? And don't forget to complete your WSQ for 6.2 part 1.